For generations, there were lights that seemed to belong only to the ends of the earth, to the poles, to the ice, to the silence of the Arctic. But one recent night, the sky broke that rule. In places where they had never been seen before, over highways, cities, beaches in the southern United States, the sky began to glow. Auroras, as far south as central Florida. For many, it was a beautiful sight. For others, a cause for concern. Is the sun changing? Is something abnormal happening in space? Or is it us who are seeing something that was always there? Auroras are not new. They have accompanied the Earth for billions of years. So why do they seem more frequent now? Why do they appear further south? Why is everyone suddenly talking about them? Is it a cosmic warning or a lesson on how we observe the universe? Everything starts at the sun. Although from Earth it seems stable, the sun is an active, dynamic, and sometimes violent star. On its surface, colossal explosions occur that release huge amounts of plasma, a gas made of electrically charged particles. These explosions launch into space what is known as the solar wind. It doesn't arrive immediately. It travels for days, crossing millions of kilometers until reaching Earth's orbit. That's why NASA and other space agencies constantly monitor solar activity following each explosion, calculating trajectories and anticipating its arrival on Earth. When the solar wind reaches our planet, it doesn't impact directly. Earth possesses an invisible shield. In its core, an ocean of liquid iron rotates slowly, generating a powerful magnetic field through a process known as the dynamo effect. This field deflects most solar particles and channels them toward the magnetic poles. That's why auroras don't appear exactly at the pole, but in large luminous rings that surround it. It's the magnetic field that decides where the sky can glow. Upon entering the upper atmosphere, solar particles collide with oxygen and nitrogen atoms. The impact excites those atoms, raising their electrons to higher energy states. But nature always seeks balance. When electrons return to their original state, they release energy in the form of light, oxygen, deep greens and reds, nitrogen, violets and blues. What we see as dancing curtains in the sky is literally the atmosphere glowing. For centuries, auroras were the heritage of Alaska, Canada, Scandinavia, and Northern Europe. In the continental United States, they simply weren't part of popular culture, not because they didn't exist, but because they were faint, rare, and easily hidden by artificial light. But that began to change. The sun follows a natural cycle of about 11 years. During the solar minimum, activity is low. During the solar maximum, sunspots multiply and explosions known as coronal mass ejections, or CMEs, increase. These ejections can be gigantic, larger than the Earth, and intense enough to temporarily deform the Earth's magnetic field. When that happens, the auroral rings expand and move southward. Currently, we are going through one of these solar maximums, not the most intense in history, but active enough to produce visible auroras at unusual latitudes. But the sun isn't the only one responsible. Here on Earth, something else changed. Cities redesigned their lighting, reducing light pollution. The air is cleaner in many regions, and above all, we can now predict auroras. Modern space weather forecasting systems give hours or days of notice on when and where to look. Before, auroras occurred without witnesses. Today, we expect them. There is another key factor: our own vision. In the dark, the human eye is poor at distinguishing colors. Faint auroras can look like simple whitish glows, easily mistaken for city lights. For decades, many auroras went unnoticed. Modern cameras, on the other hand, reveal colors that the eye barely perceives. It's not that the sky has changed so much, it's that we have learned to see it. Solar storms can affect satellites, GPS, and communications. That's why many systems are electronically hardened, designed to withstand these events. All of this is known, monitored, and expected. Auroras are not a sign of disaster. They are a natural consequence of the relationship between the sun and the earth. The lights that appeared in the south are not a warning of the end. They're a reminder that we live under an active star, that the earth possesses an extraordinary shield, and that the universe still has the capacity to surprise us. For a brief moment in the solar cycle, the sky opens up and allows us to see its invisible dance. So when night falls and the notice appears, look up, because the cosmos is still speaking.